E-Physics class presented by Fatima Convent High School, myself Dipali. Chapter 10, Light, Reflection and Refraction. Let us see how is the characteristic or what is the characteristics of the image formed by a convex mirror. In the previous session, we understood the image formation and ray diagram for a concave mirror and uses of concave mirror. Now let us understand how are convex mirror helpful to us and what kind of image do they form. The image formation by a concave mirror. We studied the image formation by a concave mirror. Now we shall study the formation of image by convex mirror. Take a convex mirror, hold it in one hand. Hold a pencil in the upright position in your hand. Observe the image of pencil in the mirror. Is the image erect or inverted? Is it diminished or enlarged? Move the pencil away from the mirror slowly. Does the image become smaller or larger? Repeat this activity carefully. State whether the image will move closer to or far away from the focus as the object is moved away from the mirror. The answers to these questions are here. We considered two positions of the object for studying the image formed by a convex mirror. In concave mirror we studied 6 positions, but in convex mirror we will study only 2 positions. Why? Because it gives a proper image only at these positions. First is when the object is at infinite distance, and second position is when the object is at finite distance from the mirror. The ray diagram for the formation of image by a convex mirror for these two positions of the object are shown in the figure 10.8a and b respectively. The results are summarized in table 10.2. Now you can observe here that when the object is kept at infinity, the position of the image is at the focus and behind the mirror. The size of the image is highly diminished, point size, and it's virtual and erect. We know that virtual image means it does not form by actual convergence of the rays and is erect between infinity and the pole of the mirror. Means any position you take at C, F, between C and F, anywhere on the principal axis, it will give a same kind of image. Between P and F and behind the mirror and diminished, virtual and erect. So do you observe here in the ray diagram, we are taking the convex mirror and the incident ray are falling on the convex mirror and are diverging after the reflection. But if you extend the diverged ray behind, you will see that it meets at the focus. Same thing if the object is kept anywhere between infinity and pole, the ray passing parallel to the principal axis and the incident ray just falling on the convex mirror after divergence, if extended behind, will form the image anywhere between P and F. This is how we understand the image formation for a convex mirror. You have so far studied the image formation by a plane mirror and a convex and a concave mirror and a convex mirror. Which of these mirrors will give you full image of a large object? Let us explore through an activity. Observe the image of a distant object such as a distant tree in the plane mirror. Would you see a full length image? Try this with the plane mirror of different size. Did you see the entire object in the image? Repeat this activity with a concave mirror. Did the mirror show full length image of the object? Now try using a convex mirror. Did you succeed? Explain your observation with reason. You can see a full-length image of a tall building tree in a small convex mirror. One such mirror is fitted in a wall of Agra Fort facing Taj Mahal. If you visit the Agra Fort, try to observe the full image of the Taj Mahal. To view distinctly, you would stand suitably at the terrace adjoining the wall. Use the convex mirror. Convex mirrors are commonly used as a rear view or a wing mirror in the vehicles. These mirrors are fitted on the side of vehicle, enabling the driver to see the traffic behind him or her to facilitate safe driving. Convex mirrors are preferred because they always give an erect, though diminished image. Also, they have a wider field of view as they are curved outwards. Thus, convex mirror enable a driver to view much larger area than would be possible with a plane mirror. So, do you understand the uses of convex mirror now? They are used in our daily life at various places. I hope the ray diagram and image formation by the convex and concave mirror and plane mirror is clear to you. Next topic we are going to see is sign conventions for reflection of spherical mirrors. While dealing with the reflection of light by spherical mirrors, we shall follow a set of sign convention called the New Cartesian Convention or New Cartesian Sign Convention. Yes, I know you are very much familiar with the word Cartesian. In this convention, the pole P of the mirror is taken as the origin. The principal axis of the mirror is taken as x-axis, x prime x of the coordinate system, and the conventions are as follows. Now, let us familiarize ourselves and recall our Cartesian coordinates a bit. We know that when we have two axes, the x-axis and the y-axis, we know that we denote this x-axis and y-axis by x and x prime and y and y prime. We know that this is the origin. We represent this by 1, 2, 3, this by -1, -2, -3, this by 1, 2, 3, this by -1, -2, -3 till infinity. We know that this is called first quadrant, second quadrant, third quadrant, and fourth quadrant. This is always positive quadrant where x and y coordinates are positive. This is negative and positive quadrant where x is negative and y is positive. This is negative negative, that is x and y both are negative, and this is positive and negative where x-axis is positive and y-axis is negative. Now this is going to help us to study about the sign conventions formed by the mirror. Now let us see how is it useful. The object is always placed at the left side of the mirror. Now convention, the word convention says that it is for our convenience to understand how it is. So we generally take it as the mirror placed on the left side of the origin. The object is always placed on the left of the mirror. This implies that the light from the object falls on the mirror from left hand side. That is, if you try to observe the diagram here, then we can easily understand in this diagram the convex mirror. The object is kept on the left hand side and the light, that is the incident ray, will move from left towards the right. Now, all the distance parallel to the principal axis are measured from pole of the mirror. That is, if this we consider as the pole, then all from, according to the number line, we know that as we move from left to right, the numbers become positive, and when we move from right to left, the numbers become negative. So pole, if we are moving from the pole from left to right, the numbers will be positive, and if we are moving from right to left, the numbers will be negative. Now incident ray will have positive and reflected ray will have negative value because it is moving away from the pole. Then we have all the distance measured to the right of the origin along positive x-axis are taken as positive, while those measured to the left of the origin along x-axis are taken as negative. Distance measured perpendicular to and above the principal axis along positive x-axis are taken as positive, and the distance measured perpendicular to and below the principal axis along y-axis are taken as negative. These are the rules to be followed for the sign convention. Now the new sign convention described above is illustrated in figure 10.9 for our reference. These sign conventions are applied to the mirror formula and solve related numericals. Did you understand now what are sign conventions? Now we will see in the next video how these sign conventions are applied to the mirror formula and what is mirror formula and magnification of the mirror.